So we are back on another video and follow up from what we discussed in previous videos about genetic testing and dopamine and links to all that. And we kind of wanted to follow up and dig deeper into serotonin, melatonin, tryptophan, because you touched up on those amino acids that being essential, and obviously melatonin being a hormone that regulates everything, and serotonin coming out of tryptophan and whatnot. Do you want to kind of open up and talk a little bit about the background of these things? So understanding serotonin, melatonin, tryptophan, and then unwrap what they actually do on a deeper level.
Yeah. Yeah. So all of these have to do with each other. All these neurotransmitters, thyroid, everything that we talked about in the previous videos, as far as phenylalanine, tyrosine, tryptophan, and histidine. These are 4 amino acids. They're very special amino acids. They're aromatic amino acids, meaning they are essentially tuned to specific frequencies of light, meaning they're like an antenna for specific frequencies of light. And when they get hit by a specific frequency of light, they are going to be essentially broken up a little bit, that then the body can later turn into neurotransmitters, thyroid hormones in the case of tyrosine and phenylalanine. But in the case of tryptophan, which is what we're going to be talking about today, it gets turned into serotonin and melatonin. And since, a lot of people are into genetic testing and testing all kinds of things, there are, there's a gene pathway that goes along with this system. And so we're going to share that today. And in that pathway, it really, really highlights the habits that we try to preach to people as far as daylight exposure and nighttime exposure and all that. It is very highlighted in this pathway. There's a reason why like if you Google any of this stuff, you're not really going to find it until you start looking into like actual medical, or not medical, but like biochemical literature and stuff like that. Or genetic testing might have some of the stuff we're going to talk about today, but it highlights that most of these things related to lack of serotonin production, lack of melatonin production, has to do with lifestyle and not with medications. In short, what I'm saying is, you're having a sleep issue, you don't need a medication. You're not absent of melatonin. You're not absent of another sleep drug. You're absent of lifestyle and behavior modifications. If you are on depression drugs, you're not absent Zoloft. You're not absent any of these drugs. Like, you're not deficient in those. You're deficient in solar exposure being one of the main ones, and we'll get into the details of that. So I'm going to share my screen real quick, and it'll kind of bring it to the attention here. So right now you can see this pathway here for the gene setup, right? And if you look at the very top, right, if you look at this top part right here, we have tryptophan, right? Now, right underneath it, it's quite interesting that 5% is found in the brain. I don't know if you can see that, but that's what it's talking about.
Yeah.
The other is found everywhere else, right? Everywhere else. So this means that serotonin, right? Serotonin reuptake inhibitor, that's only working on 5% of the system because it's acting directly at the brain level. Same thing when you take melatonin, it's acting directly at the brain level. Well, what's the other 95% of this system doing? And that is its primary function as an antioxidant, right? Melatonin, the end product over here on this other side, is its main function is antioxidant and oxidative stress for the whole body, right? So the pathway starts with tryptophan. And then if you look right over here, vitamin D and daylight are highlighted right here. This increases the conversion of tryptophan to 8 to 5 HTP. And then, depending on dopamine, or the amount of dopamine you're making, serotonin will then be made, right? So this pathway is dependent on the first pathway that we talked about last week, as far as the dopamine pathway. And that conversion has to do with how much sunlight you're getting, and how much dopamine you're making from that sunlight will then convert to serotonin. Later, if you move over to the right over here to the melatonin side of things, you notice that there's night and darkness and stress that are highlighted here. That means that serotonin will not get converted to melatonin appropriately without darkness and absence of blue light or stress. Blue light is a stress. Blue light actually activates the cortisol response that we've highlighted in many videos. And so it raises stress. If stress gets raised, serotonin to melatonin doesn't get produced nearly as much. That is why blue light circumvents or dampens melatonin production. It's, and how I say, hey, you want to regulate how much blue light is getting into your eyes at night, not because it has something special. Like blue light is not anti-melatonin. Blue light is pro-stress, and pro-stress reduces the conversion of serotonin to melatonin. And darkness increases the conversion of serotonin to melatonin. And then if you look over here, right on the side, there's a little dashed line, and it says ROS, reactive oxygen species, and UVB. So it's literally talking about UVB light, sunlight, and the amount of reactive oxygen species that's made at the cellular level is what then turns this melatonin, which is fat soluble, into 6-hydroxymelatonin, which is water soluble. So now it can cross membranes and it can cross blood-brain barriers, and it can, you see, that's how it gets activated, is by UVB and reactive oxygen species going from a fat soluble melatonin molecule to a water soluble melatonin molecule. And now you can see why it's very important in the 95% of the body that it's not your brain, right? So melatonin and serotonin are crucial for not just controlling mood, right? Most people are going to associate these two things with mood and sleep, which is mainly thought of up in your head, but they do a lot of action below the neck, mainly in the protection against reactive oxygen species through the antioxidant effect of melatonin. So they're all linked together with essentially telling you or letting you know that if you are missing morning daylight, if you are missing vitamin D, which only happens in the middle of the day with the strong UVB, you're essentially modifying this pathway to the point where you're probably going to have more anxiety, more stress, and more inflammation. If you notice, most of these over here on the other side are relating to chronic stress. Inflammation will go up if the serotonin pathway doesn't take this path. Let me clear this real quick, and I'll use a different color and show you. This red pathway, if tryptophan doesn't flow in this particular pathway, then it ends up being moved around through other pathways and then eventually excreted out, right? And all of these other pathways will lead to more inflammation. And these over here, these are things that are going to inhibit serotonin from even being able to move to the right. Things like pesticides, things like a lot of caffeine, a lot of smoking, acute stress, and chronic stress. These are all inhibitors of these pathways over here. So these are all the things you want to avoid over here on the left, circled in pink right here. And everything in the red is what you want to accomplish, right? So if you're wanting to accomplish the things that you want to essentially focus in on are a lot of daytime activity, exposing your skin to, and mainly your gut, right? So serotonin is the most abundant neurotransmitter made in the gut. That is the one that's going to be made the most in the gut. So it's going to be your stomach area that's going to influence the most amount of tryptophan turning into serotonin in strong sunlight. And then the absence of light or darkness at night when it's supposed to happen, and that will raise the conversion of serotonin to melatonin.
So this brings me to the question, like, what do people do in places like UK where there's very little to no sun, and if you walk around without a top on, you're going to be looked at as a weirdo? And maybe is there some kind of food that they can consume that can, because it's related to gut, maybe instead of getting a sunlight on their stomach, maybe they can consume some kind of food that can bypass that stuff? Or is there some kind of things that people can buy and use at home that can potentially give same exact effects?
Yeah. So there are supplemental 5-HTP supplements, right? 5-HTP is a supplement you can take it. That's the precursor. That's the one step down from tryptophan, but it's not serotonin yet. And as you saw in this pathway right here, let me just share it one more time so we know what we're talking about here. If we look at this 5-HTP5 or 5-HTP right here, it's influenced by dopamine, right? So you can take this supplement. This supplement is available pretty much everywhere that I know of. It's not regulated by any means, but the conversion of it to serotonin will be dependent on dopamine. So go back to everything that we talked about in the previous video last week. If you're not making enough dopamine from melanin, or you don't have a high melanin reserve, you're still not going to convert 5-HTP5 to serotonin. And then your only option are serotonin reuptake inhibitors, which are SSRIs. And at that point, what's happening is the little bit of serotonin that you do have is not being allowed to be excreted through urine, right, at these other pathways over here. So the serotonin reuptake inhibitor stops serotonin from being moved around external and excreted and keeps it in the system systems to keep things running. So in the summertime, in the UK especially, it is the time where you have a very short season to make this all happen. Because again, these are able to be made in abundance. And then there are almost like safe savings accounts for these types of, in the case of dopamine, it's your melanin structures. In the case of serotonin, there are all these other and acetyl serotonins that will be converted. And those nothing's really going to happen to those until they get activated by darkness. So there is a way to build these up, but not if you don't have them to begin with. Does that make sense?
It absolutely makes sense. And let me know if I think correctly. Could that be the idea why there is such a large culture of stress eating and drinking every night, of consuming alcohol just to de-stress?
Yeah, because essentially that's how this pathway kind of highlights that, right? During the day when you've been outside, you're going to convert a lot of this tryptophan into serotonin, and then when nighttime happens, if you have lots of serotonin, you are going to de-stress when darkness comes, right? So if darkness never comes and you're under artificial lights every single night, you're doing the opposite of what's naturally supposed to happen. Instead of lowering stress, you're raising stress. Now you have to come, none of your serotonin is moving to melatonin, which is an antioxidant, right? It's going to prevent cellular stress. Now you're essentially your body is looking, craving, whatever words you want to use there, to figure out a way to de-stress. And alcohol consumption and things of that nature, especially from the GABA, alcohol probably more than other things, will induce GABA and kind of lower the tone of the body, the anxiety, et cetera, and feel like you're de-stressing. But there's other negatives that come with alcohol consumption. But yes, essentially that's what your body's looking for. It's looking for a way to de-stress at some point in time. It has to de-stress. The natural way to do that is with darkness, and that just doesn't happen very often for most people, mainly because they're not aware of it, right? Like I coach people all the time, and once I make them aware of this and just tell them, okay, I mean, I'm not telling you to make the whole house dark the moment the sun goes down, but knowing this makes you behave slightly differently. Like, for example, if you want a good night's sleep because you got to get up really early or something like that, or you're just a very busy person, and you start to understand, hey, if I get out in the sun for a little bit in the mornings and during the middle of the day, it doesn't have to be very long. And then in the evening, an hour before I really want to be in bed, or, an hour and a half, I make sure that it gets as dark as as I want, ideally blocking as much blue light as possible. And then next thing I know, melatonin is much more elevated and I feel relaxed. Immediately I start to feel relaxed within an hour of making that light change in my environment. And now I get a good night's sleep. This has been the case with just about everybody that I work with, in terms of once they know the information, they start to behave differently. And just a little bit of a behavioral change makes a big impact, because these are all key amino acids and key neurotransmitters that make the whole circadian system work correctly. Meaning now, and I want to preface this with saying this: circadian mechanisms are not about when you go to sleep and when you wake up. They are about effectively transferring the, how would I call, the manufacturing facility that's your body, your pharmacy, right? Your own pharmacy inside your brain and inside your body to nighttime mode, where nighttime hormones and transmitters should be made versus daytime hormones and transmitters are being made. Most people are running on daytime mode exclusively, and that's a quick way to run down the system.
In your personal experience, do you see that there is a more kind of an incline of these issues to be in more of a like high achiever realm, where they just work 24/7, always on a laptop and whatnot? Because now we expose ourselves to our screens all the time. Do you see that kind of inclination towards that, or is this across the board, like applies to everyone?
This right here. So I'll use this other slide that's similar. It's simplified, right? And it shows all the amino acids together. So I'll show this one instead. So in high achievers, people with a lot of demanding job, they have a high demand on themselves, right? And they're always going. I actually see this pathway, the very first pathway, being affected more than the tryptophan pathway, mainly because they're running the engine so hot that they don't really sleep, but they just pass out, right? So they're not getting good quality. So it's not that this is not impacted. It's just that they're not noticing the impact because they're just tired at the end, right? And they just fall asleep. And what I like to call it is, you're not going to sleep. You're just passing out at that point. And they're like, well, I sleep for 8 hours. I'm like, yeah, but I mean, the quality of sleep is probably not that good. And then once we just implement just darkness at night and some blue light blocking at night, at a minimum, there are some other things that you could do, depending on what is actually affecting this pathway. Then they start to notice, oh, wow, I got really good sleep. And most of the time, what I hear about that is that they've had their first dream in a while that they can remember, right? Maybe it's a year, maybe it's 6 months, maybe it's longer, but they are having dreams once again, or reporting dreams once again. And that starts to tell me that melatonin is now being secreted correctly and keeping you asleep, because melatonin is a hormone that signals the start of the night, right? Just like cortisol is a hormone that signals the start of the day, right? So that means that there are other pathways that are going to be engaged to the melatonin cycle. One of them is inactive thyroid, T4. It's going to be activated and started its production about 90 minutes to an hour after being asleep. But the way that it functions is, you don't just go to sleep and then the T4 starts to be made. Melatonin puts you to sleep, and melatonin tells the pathways to turn on, right? And so now you're asleep, T4 production goes up. After T4 production, now there will be some growth hormone signaling at night. And then in order for growth hormone signaling to be appropriate, there would need to be a low insulin value, right? That's how it works naturally. So after you're asleep, after your digestion is done, your blood sugar is low, you're already asleep, melatonin has already put you to sleep, thyroid has already been made, now growth hormone will be secreted. After the growth hormone secretion process, then there's leptin. Leptin then enters the hypothalamus around midnight or a little bit after, and that's going to tell the body to essentially account for how much body fat, aka energy, and useful substrates like stem cells and other hormones that are located in fat. So it accurately accounts, hey, this is how much of all of these things this person has. And that then starts to set the tone for how much T3 to be converted from T4 from earlier in the night, because then the next thing that starts to happen around 2 or 3 a.m. is that conversion of T4 to T3 starts to happen, so that you start preparing for the thing that comes next, which is waking up and being active sometime around 5 or 6 a.m. And so that whole system runs in a secular manner and never gets pulled back. You can't make up, right? You can only try it again the next day, right? So if you, just like you can't make up sleep, you can't make up the production or the turnover of these systems from night to day. You can only try again the next day.
Is there any gadgets that can predict that this is not going right? I mean, Oura rings, Whoop bands, and whatnot. You mentioned many times. I'm just a kind of a reminder about, like, how You go from deep sleep, light sleep, REM sleep, and whatnot. So if I check my sleep scores on any kind of gadget I use, and I see that my REM sleep is non-existent, what do you immediately think of?
Yeah, the first thing that I would say is I start asking about your behavior at night, right? The first thing I do is, are you getting enough darkness, right? Because I don't automatically assume that you're not getting enough daylight, right? That may or may not be true, but the first thing I go is, what's your behavior in the first or the last 2 hours of the day, right before you go to bed? What is going on there? And if you're telling me, you're emailing people back, you're scrolling on screens, or maybe you watch a TV show, then the first thing I do is some low hanging fruit, right? So maybe some blue light blocking glasses, or maybe some, changing of light bulbs, turning off blue lights above head and reducing them down. Anything that will start to convert to tell me if you actively have enough serotonin to convert to plenty of melatonin.
Mm.
So that's the first place we start. And back to the gadgets, right? The gadgets, like the way that they're monitoring sleep is a little bit frustrating in terms of telling them, oh, this is the amount of sleep you got, whether it's light sleep, deep sleep, or REM sleep. All it is a proxy, because all it's really capable of measuring is your heart rate and electrical signaling and body temperature, right? So with the algorithm that it runs, it tries to predict whether you're in light sleep, REM sleep, or deep sleep. Doesn't mean that it's actually registering brain waves, right?
Mm.
That's like if there was something that actually registered your brain waves, and because REM sleep is only alpha waves, right? So if you told me, hey, I have a device that measured my alpha waves, now you're actually monitoring, are you in REM sleep, right? So something as a caveat with Aura rings and Whoop bands and all that. I'm not saying they're not useful. I'm saying they're not actually monitoring your brainwave activity. But if you did have a device like that, then yes, that would be one of the main things that I would look at, as far as is this pathway working correctly or not. And if it isn't, right, then I work backwards. I start with nighttime first, because you could have plenty of serotonin. You're just not converting it to melatonin, and therefore sleep is not working correctly. If that doesn't get rectified, or it only gets rectified a little bit, then I start looking at, okay, what's your behavior around noon, right? Or middle of the day. Number one, what season is it, right? Is this something that we can correct right this moment because it's the right season, right? Is it summertime and I can get you outside and fixing some of that? Do you live somewhere where there's UV light year round, right? And if the answer is no to those questions, then the next thing that I possibly do, if we come to the conclusion of, maybe you're already on a SSRI, right? Like you're contacting me because you have sleep problems, but you're taking an SSRI. That immediately would jump to, oh, this problem is actually at the serotonin level, not at the melatonin level. And so then you start, in that case, I would say, hey, some UV light, a tanning bed here and there, or even going out of your way to do a combo therapy of infrared therapy beds with UV beds combined, would be useful at that point in time. We get, especially if you're eating amino acids, right? Like if you are eating high quality protein, you're getting tryptophan. So we know that part's taken care of. So now can we convert that tryptophan to serotonin? What did we see in this gene pathway? That's the conversion of tryptophan to serotonin is heavily influenced by vitamin D and daylight, right? So we would try to simulate that as much as possible. There are devices out there, and you don't want to go with like a SAD, like a SAD light, which is just really, really, really bright light. You actually need the right wavelengths, which would be UVA and UVB light. So you would actually need a tanning bed, and I would combine it with some infrared therapy as well to upregulate all the processes with the conversion of tryptophan to 5-HTP. And then coincidentally, that's going to raise dopamine in that circumstance, because UV light takes tyrosine and turns it into melanin and dopa. And we saw in that pathway that dopamine is heavily going to influence 5-HTP to serotonin, right? So you kind of start killing a few birds with one stone of trying to simulate daylight. And there are lamps out there. You could use in-home lamps like what is it called? I'm blanking on the name. It's called a Fiji lamp or a vitamin D lamp. Spurdy D, that's the company. Spurdy D lamps. Those are small lamps, right? They're about the size of your torso that are a UV lamp. Think of it like a tanning lamp. But in that case, right now you can bring it into your home. And if you have an infrared light therapy device as well, you're getting both, right? And I teach people to do that type of stuff. Some people have some hacks where maybe they live in Canada, maybe they, up north where the season is limited for this type of stuff, or they contact me at the wrong time of the year, but they have enough money that they can buy this setup for their home gym or their home sauna, right? So that maybe they have an infrared sauna, so now they just buy the UV light that can go inside of that. That's really the way that you start looking at fixing this at the root cause, right? If it's the wrong season, instead of taking a whole bunch of supplements trying to fix it, because most of them are dependent on other pathways, let's start getting at the root cause, which is you're deficient of certain light frequencies. I know that sounds really weird to say, but you are just a complicated plant, and plants need very specific light frequencies to grow, and so do you. You need very specific light frequencies to function normally. It doesn't mean you can't for a period of time, because we have a reserve mechanism. All of these have a reserve mechanism because we are built to be able to survive winter and that sort of seasonal change. So we do have a reserve mechanism, but if you ran the reserve mechanism empty, over the course of decades of poor lifestyle behavior, then the only solution is to fix it at the root cause.
So bringing back to genetic testing, is there something in a genetic testing, DNA testing, that can tell you, hey, you know what, you are more, you will have the more benefit by living in this area on a planet? Is there something like that we can pick up and let's say, hey, you definitely
Well, yeah. So all of
struggle if you live near the equator or whatever.
Yeah, yeah. So most of these. So let me just kind of highlight a couple of these, and I'll share my screen once again. We'll bring up the methylation pathway and the dopamine pathway, and because we've talked about those in terms of those are all genetic tests that you're going to be able to see essentially. And if they're overabundant, right? If they're more flexed, all of these are more flexed to, hey, you're kind of just dumping everything, then yeah, I would say, yeah, you'd probably be worth moving somewhere with a better stable seasonal sunlight environment to turn these pathways back into the right direction. Because like we highlighted in our very first, the gene focus type of talk, which was the methylation one, that is when you start to change these, right? So right now, let's bring up the dopamine one. Here we go. Okay. So if you look over here, these little bubbles, these are genes, right? So this pathway, this dopamine pathway, is heavily dependent on the COMT gene, the MAOA gene, MAOB gene, every single one of these bubbles, and which is a set of letters and numbers. These are genes, right? And so if you start to see, hey, my MAOA gene and MAOB gene are really hyperactive, that means you're dumping a lot of this stuff right here in the dopamine pathway right out to the urine. In other words, it's not going through the full effect, right? Now, if we go look at the serotonin one, right? If we look at the serotonin pathway that we were just talking about, see these MAOB, MAOA genes, they're the same genes, right? The dopamine pathway and the serotonin pathway are using the same ones. And if we see that those are overactive, we know that serotonin is not going over to melatonin, right? It's flowing down, and where does it end up? In the urine, right? So you're excreting it. You're not actually moving it to the right and making full use of your serotonin. So the MAOA and MAOB genes, those are crucial to look at if you start looking at how they're active. Yeah, it tells me that you're moving a lot of raw substrate right to your urine. You're not actually making full effect on that. If we go look at the next pathway here, let's see this one right here. This is a methylation pathway. Let's clear all drugs. So if we look at this one, we see that in this pathway, there is no MAOB gene or any of those. These are different gene setups. So the methylation pathway won't, if you see that your MAOB and MAOA genes are overactive, they're not really affecting methylation. So your methylation pathway won't be affected, right? So you can quickly start seeing how some gene pathways and some pathways are heavily influenced by a certain set of genes, MAOA, MAOB, CMOT. Those are big ones to see if they're overactive or not. But, if you have those, that doesn't mean that it has anything to do with methylation. As you can clearly see, none of those genes are involved in methylation, right? Whereas they are heavily involved in dopamine and serotonin, right? So if you have dopamine serotonin issues, an MAOA test, CMOT test of those genes could tell you right away what's happening. But from the talks that we've had and stuff, you can quickly start to tell without even gene testing what's going on, right? Just by understanding that it's about the switchover mechanism, right? The switchover mechanism of, are you clearly active and setting the tone for the day by having a nice high cortisol response with daylight in the morning? That's going to set you up for good dopamine production and good conversion of the baseline stages of the neurotransmitters that need to be made. And then if nighttime is happening correctly, then the next cascade starts to kick off. So simple questions like, what time do you go to bed? Right? What time did the sun goes down? If it was 5 hours, right? If you tell me, hey, I'm consistently going to bed 5 hours after the sun goes down, the first question I want to ask you is that necessary? Are you doing that on purpose? Or is it just happening, right? If the answer is, it just kind of happens, I don't feel like I'm tired, then the next question comes, okay, what kind of light behavior are you engaging with, right? At that point, the sun has gone down. Why are you up for another 5 hours? If you're telling me it's because of work, okay, well, now that's a thing we have to work around, right? And I do work with people in shift work, right? And now that's when you have to employ some unique strategies to still get that switchover effect of the body clearly, hey, when you're done working, I want you to switch over to nighttime mode as quickly as possible. But for most people, if you're not working swing shift, it's as simple as just changing some habits, right? If you're telling me that you have a motivation problem, a activity problem, right? You're just brain foggy and low motivation all day long. That tells me it's probably a morning issue. It's probably a daylight issue, right? Because of how these systems are set up.
It's almost a gene testing. If it's something that you have done, it might be an overkill and overlooking the easy fixes. So, and instead of doing that and starting to take loads of supplements, you're probably better off is checking in with yourself first. Hey, are my daily habits lighting up with what I'm actually trying to achieve, which is good health? And more often than not, we all know that we are living nowhere near optimal, so to speak. And there is always improvement to be made.
Yeah. Yeah, there usually is. And so it's, it highlights our very first video now that we've gotten into a lot more details and all the nuances of why it's so important to just get outside first thing in the morning, get outside periodically throughout the day, make sure that you're cultivating good environmental light change at night. These are all things that we've been talking about right from the very beginning, literally episode 1 of setting up the day correctly because of how all these genes and all of these amino acids affect hormones and neurotransmitters. So the simple solution is, can I get back to those first line habits that we first put out? Or maybe I'm not even doing those, so I start implementing those. And then, and only then, if things are complicated after that, right? And they always are, right? Is, hey, there's still this one thing that it's not quite fixed, even though I've implemented some of these changes. A lot has changed positively, but maybe I have chronic diarrhea, for example, or maybe I fix my sleep, but I still feel like I have a gut inflammatory type of thing. Or maybe I fix the gut, the gut thing gets fixed and the sleep thing gets fixed, but I have tendon ligament type issues that are going on. That's when things start to get a little bit complicated, and maybe some gene testing is appropriate at that time to get a finer look at exactly where we need to go look. and stuff like that. Maybe it is you're missing some kind of B vitamin that we're not accounting for in your diet, like B1, thiamine. It's super crucial for some of these cascades to happen correctly. And so then at that point in time, start with the low-hanging fruit stuff that's free, essentially, just that requires work, right? Like none of this is free. Technically, you're not going to do it without thinking. That's the problem in the life that we live as modern humans, is you kind of have to go out of your way to do some of these things now. Whereas, 50 years ago, nobody had a choice. You got up and you went to work. You went outside every single day. And then when the night came, you kind of just turned off the lights, right? Like there wasn't a thing that, sitting on a screen at night was not a
lights were
thing.
different as
right?
well.
That's not a thing 50 years. Absolutely, right? There wasn't any blue lights. In fact, they were all incandescent light bulbs. Those don't have blue light. They're only infrared and red and orange, right? There's no blue light to disturb your melatonin production. In fact, they've done studies on this. Candlelight disturbs 2% of your melatonin production. Incandescent light bulbs disturbs 20% of your melatonin production. So it does disturb some, but very little. LED lights disturb 80 to 90% of your melatonin production. So think about that only in the last 20 years, right? Since essentially the 2000s has the big LED push been pushed. And that's when the most amount of disruption has happened to sleep problems and neurotransmitter problems, because you're circumventing these genes that we talked about today. The serotonin, melatonin pathway genes, which are not just sleep and mood, they are also antioxidants for reactive oxygen species. What do we know about reactive oxygen species in the medical literature? Too much of it can cause cancer. What has been happening in the last 20 years? Cancer rates have been going not like this, but like this, right? Again, lots of other environmental factors, but they all have to do with your body managing stress, reactive oxygen species stress, reactive nitrogen species stress, etc.
And I even seen that it can cause, well, don't quote me on this, I'm just passing by idea, that it can cause females specifically to reach puberty quicker.
Yeah, no, yeah. I think you're talking about the lighting. The lighting will do that. The reason why is because a lot of blue light accelerates growth and aging, right? A lot of blue light will, so at first that sounds like a bad thing. If you're 40 and next thing you know, you're acting like you're 50, that's a bad thing. But what if you're 10, right? It accelerates the maturation stage of how the mitochondria mature cells and things of that nature. So that's 100% true. It can do that if you're exposed at the wrong times of the day to artificial light and you're young.
Yeah. Well, that's what you see. Kids grow very quick now. So, but being mindful of your time, I'm going to let you off. It's been really, really, really deep understanding about all these topics. And I'll catch you in next video.
Awesome. Thank you very much.